The first part that we're going to look at is going to be this 2-axis mold plate, which includes some die cavities as well as some holes that we'll fill in. So we can see in this file we've already got our machine loaded and our stock and our workpiece and everything defined. So we'll just go ahead and just start programming. So you can see on our layers I've got my default layer, my part layer, and a stock layer. I'm going to enable this stock layer and create a new layer called thread holes. And what I'm going to do with this thread holes layer is I'm going to use this to create all my thread holes so when I create my features I know exactly where my start points should be. So I'm going to go to a top view so I can see my part and the stock overlaid on top of it, and I'm just going to want to place thread holes at each of these holes in the die cavities. So the easiest way to do that is to go to my geometry toolbar and select points, and I'm going to create my points using snap points just at the center of each of these holes. And the nice thing is with TNG I can just snap straight to the center holes from my solid. I don't need to worry about smashing geometry or creating anything additional to help me snap these points, which just makes the whole process a lot easier. We can breeze through this a lot quicker than if we had to smash that geometry before we could create the holes. So I've created my thread holes, so I'm going to exit my point window and I'm going to go ahead and add a new layer called features. And I'm going to hide my stock layer now so that I can see everything. So now I've just got my nice clean die plate with my thread points defined. So let's go ahead and I'm just going to do a Control A to select all of my solid and thread points. And then I can go to my Features tab of the ribbon and select EDM Features. With this open, I'm going to create my die features first. So I'm going to create die features, draft conic then ruled, approach type normal, and just click OK. So now it's going to create my 11 die features. So these are all pretty good. They start with the big ones, and we've got all those good features there. So let's go ahead and create my whole features next. So I'm just going to reselect my solid. And I'm going to create my whole features in a grouping fashion. I've got a couple different sizes I want to work with. So I'm going to go holes. I'm going to create them from 2 to 2.5 millimeters initially, and that's going to give me my 12 through 23 hole. And then I'm going to repeat that process for holes that are sized from 8 to 8.5. Create that, and that gives me my 24 through 31 hole. And then I'll repeat one last time for my large holes, which are going to be from 14 millimeters to 14.5 millimeters. And the reason I split these holes up is just to make sure that I can get my groupings better. We're going to pocket those holes out, and each of our thread holes for those are going to be sized appropriately so that when we drill through that stock, we're not forced to wire away quite as much material. So we're going to optimize that stock, and that's where the different holes are going to come into place. So now that I've created my features, I can go ahead and start applying some operations. So the first step, whenever you're creating an EDM file, is going to be to start with just a set origin operation. So I'll create this and just locate my first thread point, which based on my strategy, I'm going to start by going from my smallest feature to my largest. So that's going to be this little guy right there. So that'll be my start point, and we'll explain that further along as we go. So let's go ahead and create that. So I've got my part set up. That should be my first operation in my operations list to help communicate with the post properly. Then I'm going to go ahead, I'm going to select all of my die features all in one shot. I'm going to open up a 2-axis contouring operation. And I'm going to go ahead and open a process. So that's going to be 2-axis contouring dies, and that's going to load up all my cut data, set everything properly for me so that I know that I've got everything set correctly. I've got my Misubitshi XML database here for this MV1200S machine where I'm setting up all my workpiece materials, my thicknesses, to make sure that I get good cuts. So we'll just click OK on that, and then we'll create this operation. And so we've got quite a bit added there for each of our passes. We can see that our features list, our operations list, and our program list are now quite heavily populated, which is good. That's what we're looking for as we program this part. So let me hide that feature folder that I created with my parent operations. And I'm going to go ahead and just apply some processes to my next sets of holes. So I've got my small holes here, so I'm going to go ahead, right click, open process. And I'm going to load my pocketing small holes operations and give that a second to load and process. And one key difference, as I mentioned, we're doing this by hole sizes. So what we'll notice as we apply these operations is our toolpaths for each of these are going to reflect the different sized holes, starting holes for those. So if I look at my feature for my pocketing small holes, we'll notice that my hole diameter is set to 1.5. So we zoom in, we see that our pocketing starts from 1.5 out. I'm going to go ahead and repeat this process now for my 24 through 31 holes. I'm just going to apply my process for pocketing medium holes. And we'll go ahead and now on this one, our through hole size is about 7.5 millimeters. So even though the rest of our pocketing operation is about the same, we're just not cutting quite as much material away, and that's good. We're just trying to optimize so that we're not forced to burn quite so much. So let's go ahead and select my last 4 hole features, and I'm just going to one more time open process, and this time I'm just going to apply my pocketing large holes, which again is the same as the small holes and medium holes, but just with that different through hole size to make sure that we're getting optimal burn. So now that all those are created, we can go ahead and simulate these and see how it looks. So let's go to our machine view, and let's just do a little simulating here. So I'm going to go ahead, simulation, and play. And we can move our speed up a little bit just so we can see a little bit better. And it's going to start with our die feature and cut through there. And we notice it's going to cut all of our die features kind of in order. And the reason for this is just that's the order that we programmed them for. So what we can do, now that we're seeing this operation and realizing it's not really quite optimal, we're going to have to sit and wait for it to burn through each part before it cuts off our slugs and then eventually does all of our pocketing. So what we want to do is we're going to want to sort these to kind of optimize things again and make sure that we're getting a good night die strategy so that we can do our roughing passes, do our cutoffs, all in one go, and then just let the machine run overnight, to make sure that we're not wasting the machinist's time sitting by watching the machine run, just waiting to pull the slugs off. So let's go ahead and stop this simulation before it runs to completion. And then we'll go ahead and go back to our part view, just so I can get a good view of what we're looking at. And I'm going to go ahead and re-expand those and go to my EDM toolbar and choose sorting. So on their sorting, I'm going to use the user filter here to select just my die features and just my contouring operations, then all my rough, cutoff, and skim passes. And I'm going to sort these by position at start. I'm going to sort my strategy as rough, cutoff, skim, so it'll do all my rough passes, then all my cutoffs in one go, and then it'll come finish up all my skims. And for my feature routine, I'm going to say feature length, and I'm going to go from small to large. That way it'll cut all my small slugs and then cut off all the larger slugs. That way we're basically making sure that the bigger slugs are not waiting as long to be removed as the smaller slugs. So let's go ahead and click sort. And that's going to sort it. So now I should have everything set up. So we've got all my rough passes, all my cutoff passes, and then all my skims for those contouring operations. Now I'm going to switch to current selection. Go to my features window, and I'm just going to select all of those whole operations that I just created. So I select all those, go back to EDM sorting, and this time I'm going to position these at the in place, so they're going to stay towards the back end. I'm going to make sure to sort by per cavity, because in this case for the pocketing, I just want to rough weigh my material and then skim at the end. I don't have any cutoffs that I need to optimize. And for my order routine, I'm just going to go with shortest path. So now I can sort those and click OK. And I'll go back to an isometric view and just let this process, because it is thinking through all these various operations, making sure that they're optimized correctly, that we're getting the right order to make sure our machine movements are correct, but it's also calculating all of our links to make sure that the movements between each of these cavities is going to be effective, not cause any collisions, not cause any wire breakages. So that's something that is important. And really helpful, and something TNG does a great job taking care of. So let's go back to our machine view now, and let's just simulate again, and let's see how that improved order may have helped our machining. So we can zoom in and take a look. So now we see we're cutting our large die first, we're cutting our other dies, and it's cutting through here. So we're seeing just our rough passes, and we're getting all of these, and our machinist doesn't have to pay too much attention to that until he comes back and gets all of his cutoffs. And once he's removed those slugs from the cutoffs, then we can just let this run overnight, throughout the day, whatever we need, unattended machining, to make sure that this die block gets cut correctly without having someone to need to sit and babysit the machine. So it's a really helpful way to be able to program. So now that that's done, we'll move on to our next heat sink part.